Hello and welcome to Interfaces in AP Computer Science, Lesson 304. So prior to this, we talked about the whole concept of extending. We talked about inheritance with a subclass and a superclass and how you pick up attributes. And recall that Java is single inheritance. Because Java is single inheritance, when you extend a class, you can only have that one ancestor. If you do not extend anything explicitly, then object is there by default. Interfaces allow us to be able to interact with the subclass in a whole different idea. So instead of having this direct family lineage from parent to child to child to child, interfaces allow us to interact with the class through an extended family. So sometimes I refer to this as like step family, sometimes this is like friends that can influence you even though they're not part of the bloodline. So if you like this idea of an interface, you can create one similar to how you create a class, but it's a wee bit different. Instead of saying public class pet, we say public interface pet. And that defines this pet interface. So it's going to have some effect on the child. It's a lot like an abstract class where it's going to have a list of things that are obligations that you're going to have to fill, but it's in a separate genre because it's an interface instead of a class. We have this method, takeWalk. Much like in an abstract class, it just has a semicolon at the end of it. It doesn't actually have a body. In fact, every method inside an interface you can assume is public and abstract, so much so that you don't even need to write them because it's just understood. This interface, much like an abstract class, is really just a list of methods that you are obligated to fill. When the child wants to use this, instead of extending, because that's the regular hierarchy thing, we implement an interface. Dog implements pet, and then we have this method, this obligation that we have to fill. Public void, public from there, void from there, and it's takeWalk. And all we have to do is say, enjoy your walk. So we fulfill the obligation of the interface. The reason you might want to use an interface is, first off, you can only have one extend slot. So that is a very special slot, and you don't want to give it away too easily. Second of all, with an interface, it allows the class to have an alias, an alternative type, that could be used for either populating an array or methods that are already written. So it gives us a lot more versatility later on. All right, so if you implement an interface, you are obligated to write a body for every method that's in that quote-unquote abstract interface. One place that you might run into this where it's kind of a weird implementation is in graphics. When you play around with the mouse adapter, it requires that you have 4 methods to interact with the mouse. The mouse clicked, the mouse dragged, it's mouse in, mouse out. I don't even remember what all 4 of them are because usually when you're writing your code, you only care about that mouse clicked. Those other 3 methods need to be in the class, but they don't need to have fancy things inside of them. You can actually just write the header of the method and then brace, and then Java's happy. You fulfilled your obligation. Even though the body is empty, as long as you have those braces there, that shows that you actively chose to have an empty body, as opposed to an abstract header that's just a semicolon with no braces at all. The second part's interesting. Once a class implements an interface, all of its children automatically implement that interface. So if higher up in the family tree, some parent implements the pet interface, all children of that parent automatically pick up that pet interface free of charge. So they have that alternative type and they have all those same methods that are obligated. So interfaces versus classes. Do they have a maximum number of methods? No, both of them can have as many as you want. When you compile them, does it make a .class file? An interface actually does. So if you find yourself working with code and there's like an interface and a parent and 2 children, you'll actually generate 4 class files just by compiling that. Much like an abstract class, you cannot instantiate an interface. It's strictly not allowed. It's allowed to be a reference type. It can be on the left when you make an instantiation statement, but it cannot be on the right. A class, of course, you can instantiate. Can you make a reference? This is that comment to the left side. Both of them are allowed to be on the left side. Can you provide a constructor? No. An abstract class, you can provide a constructor should you want, but an interface you cannot. A class, of course, you can. Abstract methods. In an interface, they're automatic. In a class, they're optional. If the class has no abstract methods, it's not abstract. If the class has at least one abstract method, the class must be abstract. Are they allowed to have variables? An interface cannot have variables. No variables at all. Abstract class, yes, but interface, no. And any class can have variables. Can it have constants? The interface actually can have a constant. So long as you have that final in your declaration, you're allowed to put that inside an interface. Comparable. Comparable is probably the most well-known interface, and it's built into Java. Basically, the idea of comparable is it allows you to rank things. Whether you're ranking strings by alphabetical order, whether you're ranking capital I integers by numeric value, whether you're ranking potatoes by their starch content, whatever you want to rank, comparable allows you to rank things. This becomes huge later on in the course when we play around with sorting data. To try and sort things, it's really nice to be able to know, given two objects, what should their rank be? Who goes first, who goes second? So a comparable interface is pretty awesome when you get down to it. The comparable interface only has a single method, and that single method is compare to, and it accepts an object other. This object can cause a whole lot of trouble on the multiple choice on the AP exam because you might be tempted to think that it's a person or a string, but it is always object other. And basically what it's going to do is it's going to give you an integer comparison because we want to have three results. Boolean's not good enough because we need A comes first, A comes second, or it's a tie. So we need those three states so we get an integer. Do not be lulled into thinking that it's always going to be a positive number or a 1 or a negative 1. It could be any number, but it's going to give them some kind of a rank. So what do I mean by rank? I mean that if you were to do apple, and because apple's in those double quotes, I can explicitly call it, and then we said bear. Apple comes first alphabetically ahead of pear, so this is going to return a negative number. A negative number means that this is going to be the first thing comes before the second thing. That's a negative result. If I were to do apple dot compare to ABC, it does go deep. The first letter is A to A, so it'll compare the second letter built into string. That saves you a whole lot of headaches of trying to play around with compare tos and or char ats to try and check letter by letter for comparison. Compare to does all that work for you. A matches up. B comes before C, which means this parameter comes before the first thing. This is going to produce a positive number, some number greater than 0, to let me know that the thing in the parentheses comes before the thing that made the call. And then obviously if it was apple dot compare to apple, it would return 0. So it's an alternative for the dot equals if you really wanted to. If you're writing a class yourself, if you're defining a football player or whatever you might be making, it is your responsibility to decide how do you compare these things. And if it's a football player, you'd have choices. Are you comparing them based off their name? Are you comparing them based off their jersey number? Are you comparing them based off their number of tackles? Are you going tackles first, then name? You could rank it any way you want as opposed to what's important in your program. It should be mentioned that the documentation for compare to is on your quick reference sheet during the test. So if you come across a multiple choice question and you're a little fuzzy, check your quick reference sheet. It's documented right there and you can consult it. So it's your job to decide who comes first. I mentioned that with football. Some people overwrite the equals method and basically just have the equals method call the compare to method if you're using this. It's not required, but it might save like 2 lines of code, and so therefore some people like it. This would be what it looked like, assuming other's not null, just to avoid null pointer exceptions. You can say compare to other equals 0. You don't have to put the thing in front because you're locally in the object and it's understood you're in the object. If you really want, you could say this dot to make it feel a little bit more like the other call. All right, so we got 3 declarations. We're making an integer, we're making an integer, and we're making a comparable. Which of these is our legal? So integer is just a wrapper class for an int that's just storing an integer with 7. The reason that this exists is so that you can store ints inside something that only accepts objects. But it has all the cool stuff that you would want. It has a dot equals, it has a toString, it has a compare to, all built into it. Integer on both sides, cool. Comparable on the left is a little bit concerning because we're not allowed to instantiate a comparable interface, but it's allowed to be a reference type. So this number 2 is actually legal. That's okay because integer implements comparable. The third one's utter fail because you're not allowed to have comparable on the right. That's the number 1 reason that's going to fail. So 1 and 2 are both good. All right, so hopefully you enjoy interfaces a little bit and you have fun doing the lab.